in this embedded C programming course, we will see what is data types in C programming. So in the last session, I showed you like how we'll be installing STM32Cube and how we'll be writing the first program for the host machine. I think all written that, right? So we were writing certain, like in one simple program we written, I think declaring some variables, and we were printing that variable status for the data, right? So that's it. So maybe in this lesson, I will be showing, like maybe in depth we will analyze what is embedded C code, okay, or maybe a normal C programming for the host machine, okay. Yeah, so embedded C code, maybe after that we are going to analyze it. So let's see the normal C code, how we'll be writing for the host machine. And from there, we can do the transition to embedded C, right? So a few more concepts like in C programming, I would like to revise here, which is very essential for embedded C, especially like data types. So data types, I hope all are clear in every programming language, in any programming language, if you're starting, maybe the first topic which you done in detail is data types. Okay. Yeah, so now let's see what is the need of data type and why we want to learn data type, and what are the different data types like in embedded programming. Okay, so here let's see, like maybe like whenever you are declaring a variable. So in the last experiment we have seen that sometime we'll be writing the variable as int variable 1. Okay, so then we'll be giving some any integer value equal to 10. Okay, sometime the data type is character or double or float. Okay, so there can be different data type. Now let's see how we are going to write, or how we are going to choose the data type. I think all are clear about it. Okay, if it is integer, write int. If it is floating point data, write float. Okay, so that's it. But maybe we are actually going like little more in depth. Okay, and let's see what is where I'll be using float and double. Okay, what is the scientific notation? So all these things we have to see one by one. Okay, so yeah, that's it. So now let's get started into that. Let's see like little bit information. Okay, and let's analyze what are the different data types. And sometime apart from the data type, we'll be using some other type specifiers. Okay, so let's get into that, and we'll write some simple programs and see. That's it. Okay. Now I don't want to discuss about the formal definition of a data type. So everybody is clear what is data type in C program. So whenever we are creating a variable, variables are like containers which is about to hold some data. Okay. So what type of data it is holding, that information we will be getting from the data type. Okay. So whenever we declared a variable, what's the syntax? Data type, then the variable name equal to, if you want to initialize it with some value, so we'll be writing accordingly. Okay. So it is always choosing the right container. Okay, so right container to hold the right data. If I am already clear, I am going to hold some floating point data. Then of course I have to choose floating point data type, right? One common example I will tell you. Suppose we are actually like taking a survey, and in that we would like to store the height of the height of a student or height of a kid. Okay, so usually in height we know like we used to write maybe 4.1, 3.2. So okay, so of course the decimal point is coming. So it's better to choose any like a floating point data type. Okay. And sometime we know like we would like to store the age. Of course, age also like floating point is possible, or maybe if you want to just store it as an integer, what's your age? 10 or 12 or 11 or whatever it is. So in that case, I will be choosing the integer data type. Now, what's the problem? For everything, I could have choose a floating point data type. Then why I am not using that? Why I am sometimes going for integer? The option is that as I told that day, so the size of each and every data type, okay, so it is consuming different sizes, okay, different memory sizes it will be consuming. Depend on the data type, the variable will be using like different memory sizes, okay. So sometime we know we are going to store a simple value, so like that time we would like to get a data type which is taking less memory. Okay, so memory management, of course, optimizing the memory usage is very crucial in embedded C programming. Like if you're writing the program for the host machine, you don't have any problem. We have the luxury, we have more memory. Okay, so memory is not even a constraint like whenever we are writing for the host machine. But that is not true whenever you are writing the program for your embedded system or the embedded microcontroller. So there the like memory will be very limited. Okay, so even if you are declaring a variable, you have to be very careful which data type you are using, whether that is required. Okay, so that data type is required. If there is any way where I can reduce, or where I can use a data type which is taking less memory, so I have to get into all these details. So then only like we can call you a better embedded programmer. Okay. So that one thing. So like let's get into that. What are the different data types in C? Yeah. So data types in C we can categorize into user defined data type, primary data type, and secondary data type. Okay. So primary data type, I hope everybody is clear: integer, character, float, and double. Okay. So these are the primary data type. Using that, you can declare any like any variable. Okay, so as per the like requirement, as per the memory requirement, we'll be choosing any of the primary data type. Then apart from that, after that, we will be moving on to the secondary data type, which can be the combination of primary data type like array, pointers, and all. Okay, so arrays and all clear, right? So for example, I'm having a data. I'm just holding the age of a student. Okay, so I can make a variable, for example, int age 1 equal to 10. Okay, so maybe for the second student I can make for the same class. Okay, class in the sense like usual, like they are studying in the same class, so same division. Okay, so again for the second student I am creating another variable int age 2 equal to 10. So similarly, okay, so if there are 10 students in the class or 50 students in the class, rather than declaring the separate like variable, what we can do, we can make a array, right? We can declare an array. Array is nothing but it is the collection of homogeneous data. So the array can be constructed. Okay, so if all the data are integer, I can make an integer array. Okay, if all the data are floating point number, then I can make a float array. Similarly, character array if all are the characters. It not mean to say in array I can store one integer, one float, okay, one character. That is not possible. I think all are clear about it, right? So array can only hold the homogeneous data, so homogeneous primary data or the user defined data, whatever it is. Okay. So I hope that's clear. And about pointers, pointers is of course important. We will be like a separate session. We will be like discussing that in detail. Okay. Yeah, so these are the secondary data type. Then we will come to the user defined data type. That is again and again, I'm saying that that is very, very important for embedded C programming structures. Okay. So most of the program, most of the embedded C program, if you're writing something like LED blinking or starting from there, you can start using structures. Okay. So where you're creating some templates. Okay. You are defining your own data type. Maybe the primitive data types are not enough for us. So we'll be clubbing multiple primitive data types. Then we'll make a structure. Okay, so that we will discuss soon. Okay, like similar to structures like union, enum, and all. So these are the user-defined data types. So the entire C programming is based on this data types only. We will discuss primitive data type, then we will discuss some operators and related stuff with that. Okay, so then we will be moving to the secondary data types. Then we are coming back to the user-defined data type. Alright, so this is actually the complete structures, like structure about data types. So here you can see the data type. As I told already, primitive data type is char, but sometimes I used to write signed char and unsigned char. Okay, short signed char. So like one more term we are adding with it. I'll show the difference why we are doing that. Maybe let's see this in the program. Okay, so one thing you have to note it down, the format specifier you should remember. Okay, in C programming, of course, it's mandatory, like if you want to print some value or if you're taking the value, so we have to use the respective format specifier. For character it is percentage C. It's very easy to remember it. Okay, so percentage D you can use it for integer, right? And for short you can use percentage D. For unsigned, short unsigned, and you are using percentage U. With practice you will be able to like remember all this stuff. Okay, yeah, all right. So this format specifier we have to like look into, we have to take care. And apart from that, you will be able to see there is a major difference here, signed and unsigned number system. Okay, so what do you mean by signed number system? Maybe take the first example. You can see we written signed char, then we written unsigned char. Okay, so by default, okay, so by default, I'm saying that by default, if you written int, okay, int variable 1 equal to 10, something if you written, by default, it will be taking as the signed number system. It's very, very important to remember by default, all data types will be signed. Okay, which means to say which can hold the negative values also, positive values also. Okay, when I told you like I am declaring the age of the student, I told int age equal to variable 1. Okay, sorry, int age equal to something, some value. Okay, int age equal to 10. All right. So here you can see that by default it's treated as a signed number system, and it can hold positive and negative numbers. Okay. So that is fine. Yeah, but you know, like already you are aware about it. If you're storing, if you are going to store age of the student, it can't be negative, right? It can't be negative. We don't have negative age, right? Of course, it will be greater than 0. Okay, 0, that means from 1. Okay, whatever it is. So we know negative numbers I can avoid completely in this like in this particular situation. Okay, so then what I can do, I can make it unsigned. Okay, unsigned integer. Then what benefit I am getting? Okay, so that is also one question. What benefit you are going to get if you are making it unsigned? Okay, so I told already by default it is signed, and if you want you can make it unsigned. So you look at the example here. It's written the range. Okay, range of numbers which it can hold. Okay, so look at here, signed integer. I'm not talking about character. not short, you can see the signed integer. Signed integer, you will be able to see the range is from minus 32,000 something to plus 32,000 something. Okay, so if I am using the signed integer, okay, so signed integer, the memory it's consuming is 2 bytes here. Okay, so that is of course compiler dependent. Okay, I'll tell that why it's compiler dependent. So for which compiler, which compiler I am using, that means end of the day which microcontroller or which hardware I am using, like accordingly the size of the variable can differ in different compilers. Okay, so we'll get into that, but anyway, just look at here. So here you can see signed and unsigned number system. Signed number system, it is storing, or maybe it can hold a value from minus 32,000 to plus 32,000. Okay, so that's the maximum, minimum to maximum value. But you can see that unsigned integer, it is taking, or it can hold a range from 0 to 65,000, which is double of the previous range. Okay, double of the positive range I'm talking, not the negative range. So negative range completely we omitted, that means in unsigned system, and that whatever we omitted, so that we are doubling for the positive value. Suppose if you want to store a like very big positive number. Yeah, suppose if you want to store your bank balance. Okay, suppose I'm having the bank balance of 60,000 rupees, suppose. Okay, so like which variable I can use? 60,000, right? Then I can use like integer. Of course, integer is taking only 4 bytes. Why I can't use float or double? I don't have problem for 60,000. Even I could have choose float. But you can see the size of float variable is 4 bytes. Okay. So again, double is 8 bytes, and I don't want to like use like unwanted memory. I don't want to waste memory like that. So I don't need 4 and 8 bytes, because with 2 bytes I can do the task. Okay. So I'm just choosing 2 bytes memory, which will be consumed by integer. Okay. So in this example, I know the balance usually we don't want to keep it negative. Okay. We can make the error message or something. If your bank balance is less than 0, you can give a notification, or you can just print that it's an invalid balance. Okay. So maybe the bank don't want even to get negative balances. So what we can do, I can write clearly my variable. Okay, so balance variable. So I can write clearly unsigned int balance equal to 60,000. So what's the benefit I am getting? First of all, I am choosing integer only. So integer is taking 2 bytes. And why I written unsigned? Because my balance is 60,000. If I am simply writing int, okay, int balance, what will happen? It will get treated as signed number system. And signed number system, as you can see here, it can hold maximum 32,767. Okay, so that value only it can hold. Okay, then if I am trying to store 60,000, of course, it will be showing some. It won't show any error, but it will be showing some like other values which we are not expecting. I'll show you why it is so. Why it is showing some value which is out of range, or maybe like which we are not expecting. Okay, so that reason I will tell you. But anyway, end of the day, it's clear that it can hold 32,000 only. So of course I can't keep 60,000 balance in that. A very simple example I have done, like with the 2 bytes only, I'm able to do the task just with the like a keyword, additional keyword called unsigned. That's it. So I hope it's clear where to use signed and where to use unsigned number system. Okay. All right. So most of the time in embedded programming, if you are writing, if you are writing the data type for the registers, okay, so some register variables and all if you're like creating, most of the time we'll be using unsigned integer only. Okay, so we can double the positive range of value, then you can hold the maximum data. Okay, so maximum values for that, like for that data types. Yeah, so this is overall at a glance. I just showed you that what are the different data types, and so I told one more thing. The like whatever. Okay, so the number of bytes it's consuming is compiler dependent. Okay, if you are using 16-bit compiler, it is accordingly. If you are using a 32-bit compiler, accordingly. So let's see. Let's don't guess anything. So maybe in this like here itself in this ID, cube ID, we'll try to write the different data. So, okay, so data type, that means we'll create different variables, and using a size of operator we'll be able to find how much memory it's consuming, how much bytes it's consuming. Okay, so that won't be a difficult task to find out, and even we don't want to remember. Okay, so this is how we will be using the size of operator. The syntax is very simple, size of. Okay, so inside the size of we can write the data type or maybe the variable name. Okay, so variable name of course will be having a data type, right? So it will be able to show that what will be the data type it taking for integer or for character. Okay. So like for float or double, whatever it is. Okay. So here the output can be different on different machine whenever you are using size of operator. Okay. So like a 32-bit system can show different output, while a 64-bit system will be showing a different output, of course. Okay. So maybe you heard about Turbo C compiler, Turbo C or C++ compiler. That's a 16-bit compiler. For the 16-bit compiler, short is 2 bytes, int is 2 byte, and long is also 2 bytes. Okay, sorry, long is 4 bytes. And for a 32-bit controller, like a 32-bit compiler, okay, so 32-bit compiler, of course, is used for 32-bit like a microcontroller, right? So whenever I'm using a 32-bit compiler, you'll be able to see that short is 2 bytes, int is 4 bytes. Okay, so int will be 4 bytes and long will be 4 bytes, right? So you can see the difference for integer. You can make a thumb rule. Integer always will be taking the compiler size itself. Okay, so 32 bit means how many bytes it is? 32 divided by 8. Okay, 4 bytes, right? So integer size always will be giving you the compiler size. For example, in my ID, okay, so the cube ID which I am using, if I don't have any clue what is the compiler size, I don't have any clue. So what you can do, just write size of then integer. Okay, so maybe in cube ID, if it is showing size of integer is 4 byte, just understand that it is a 32-bit compiler. Or maybe in some other ID, if you are writing size of int, but you got maybe 2 bytes. Okay, which means to say you are using the 16-bit compiler. 16 by 8, right? 2 bytes. Okay, are you getting the comparison? So like that, even we can guess what is the size of the compiler. Very simple calculation. Integer always will take the size of the compiler itself. So which operator we discussed? We discussed about the size of operator, and that is helping us to find the size of any data type. Alright, so now I think let's go to the program. Okay, so let's do few programs and all, then we'll come back. Otherwise it will be completely like all are listening. Okay, so not doing anything. Okay, I don't want to do that. So let's open our IDE and start writing the first program.